Alright, in the last lecture we have learned common operations that can be performed on circular queue using array. Now in this lecture we will implement a queue using linked list. So let's see how it works. So the first operation is creating a queue. To create a queue using linked list, firstly we need to create an object of single linked list class. So when we create an object of single linked list class, it basically creates a blank head and a blank tail. So the reference of head and tail right now is null, so there is not any node in this linked list over here. So when we are creating an object of linked list class, we are successfully creating a queue using linked list in this case. So once we have created a blank queue, the next thing that we are going to do, we need to enqueue elements to this queue over here. So let's see how do we do that. So in case of enqueue method, the first thing that we are going to do, we are going to create a blank node and we are going to assign a value to it. Then we need to change the head reference to point to this node over here and the tail reference to point to this node over here. Now we know that if we update the physical location of this new node to the head reference, we are going to create a link between head and this node over here. Now the physical location of this node is 111, so I'm going to set 111 to head reference. So with this we are creating a link between head and this node over here. Then we are going to update the tail reference. So similarly, I'm going to update the physical location of this node to tail reference. So with this, we are creating a link between tail and this node over here. Now after doing so, our element is successfully enqueued to this queue over here. Now we know that when we are enqueuing elements to the queue, each new element will be located at the back of the previous after the previous element. So in this case, when we are enqueuing one more element in this queue over here, it's going to insert an element at the end of this linked list over here. Now similarly, if we want to insert one more element over here, we are going to call enqueue method. So here again we are going to create a node and then we are going to assign value to it. Then in this case we are going to update the previous node's next reference to point to this node and tail's reference to point to this node over here. Now we know that previous node's next reference points to null, so if we update the physical location of new node in the previous node's next reference, in this case we are going to create a link between this node and newly created node over here. Then we are going to update the tail reference to point to this node and a link between tail reference with previous node gets destroyed. Now with this we have successfully inserted a node at the end of this linked list. So with this, a new element is enqueued to this queue over here. Now if we continue to the third element to enqueue the third element, in this case also the operation is similar. So we are going to create a node and assign value to it. Then we are going to update the last node's next reference to point to this node and tail next reference to point to this node over here. With this, we have successfully inserted a node at the end of linked list. So a new element is enqueued to this queue over here. Now you might notice that whenever we are inserting a node to the queue, it's inserting after the previous node over here. So basically, in case of linked list, when we are enqueuing a node to the queue, we are inserting a node at the end of linked list. Because in queue, when we are inserting an element, we are inserting a node at the end of the queue. So this is how enqueue method works in case of queue using linked list. Now let's see how the queue method works in case of the queue with the implementation of linked list. Now in this case, we know that when we are dequeuing the element from the queue, we have to return the first element and we have to remove the first element from this queue over here. In this case, when we call the queue method, we have to delete this element from here and return this element from here. Now we know that if we want to delete element from linked list, we are going to change head reference to point to the second node. Now the second node's physical location is 222. So if I update the 222 to the head reference, then in this case it's going to create a link between head reference and this second node, and a link between head and first node gets destroyed. Now with this node is not referenced by any node, so it's going to be deleted by garbage collection, and this element will be enqueued from the queue over here. Now if we continue to dequeue the one more element, here again the operation is same. We are going to update the head reference to point to the second node, and a link between head and the first node over here gets destroyed with this update over here. After doing so, a link between head and this first node gets destroyed, and this node is not referenced by any node, so this means that the garbage collector comes and deletes this node from the memory. So with this node gets destroyed from the memory, and we have successfully dequeued this second element from over here. So this is how dequeue method works in case of queue using linked list. Now let's continue to the next method. The next method is pick method. Now we know that in case of queue, when we are calling pick method, it's returning the first element from the queue. Now our first element in the queue is 1, so this element is the first element in this linked list over here. So this means that whenever we are calling the pick method, it's going to return the head value, because head points to the first node. So in head we have first node's value. So this means that whenever we are calling the pick method, it's going to return head value in case of linked list. So it doesn't matter how many times we are calling pick method, every time it's going to return the first element, because pick method is different than the dequeue method. In case of dequeue method, we are removing element and returning it, but in case of pick method, we are not removing the first element, we are just returning the value of it. Now let's continue to the next method. The next method is empty method. Now whenever this linked list head points to the null, in this case it means that our linked list, we don't have any element in our linked list, and this means that our queue is empty. So this empty method works like this. If head is null, it's going to return true. Now in this case we have elements in our queue, so this means that this queue over here is not empty. Now in case of linked list, we don't have isFull method, because here the queue size is variable, so we can insert how many elements that we want to this queue, so it will never become full. So that's why isFull method is not available in case of queue using linked list. Now the next method is delete method. So whenever we are deleting a queue, in case of linked list, we are going to set head and tail references to null. So with this, all these nodes over here will be eligible for garbage collection. So garbage collector will come and delete these nodes from here. So the algorithm will be like this. We are setting head to null and tail to null. So after doing it, a link between head to first node gets destroyed, and a link between tail to last node gets destroyed. Now after deleting these links over here, we see that the first node becomes eligible for garbage collection. So this means that garbage collector can come and destroy this node from here. So with this element is deleted from the memory. Then the second element becomes eligible for garbage collection. So the garbage collector destroys this one from the memory, and this one is deleted from this memory. And then at the end, last node becomes eligible for garbage collection. So garbage collector deletes this one from the memory as well. So with this, we have successfully deleted queue from the memory. Now with this, we have come to the end of this lecture. So in this lecture, I have shown you how these operations work in case of queue using linked list. Now in the next lecture, we are going to implement these operations in practice. So see you in the next lecture.